All right, so what we're going to do is we're going to look at negating conditional in this section. All right. And basically what we're trying to do, and remember when we said negating in the very original introduction, we think about trying to prove something false. Okay? So for instance, if somebody says the following statement, if you are tall, then you can play basketball well. How would you prove that false? Well, it's pretty clear that you just need to find one person who happens to be tall and does not play basketball very well. All right? So think about this. If you are tall, then you can play basketball well. I'll say this in a second. So tall is in here, then you can play basketball well. What we're saying is essentially all these tall people in here can play basketball well. All right? So basically all we have to do is we have to find one tall person who doesn't play basketball well. Who, in other words, we just have to show that there's a tall person. Oops, I should have erased it that way. And instead of all tall people, there's somebody out here. There's some guy, or male or female, I guess, doesn't matter, over here, who is tall but happens not to be in this set of people who play basketball well. All right. That's what I want you to think. I want you to think when you're trying to negate a conditional, you want to try to prove it false. Now, in the previous statement, I just said we can find one person. But all you have to do is say some tall people do not play basketball well. Notice that this is not an if-then statement, okay? If-then statements aren't really negated by other if-then statements. If-then statements are negated by a statement which starts off as some blank. Or there's some other ways too, but notice that we're not trying to say all tall people don't play basketball well. We're saying that I've found one tall person that doesn't. And at least one, if you recall from the very first section, that's what it means to be some, right? At least one. So I want you guys to push pause on the video and give the negations for the following two statements. All right, so for the first one, you should have gotten that some cats named Charlie are not crazy. Okay? By the way, remember, if you recall, I don't know if I actually did this before or not, but a same statement to the if the cat named Charlie, then the cat is crazy, is saying all cats named Charlie are crazy. Oops. And so to negate an all cats named Charlie are crazy, some cats named Charlie are not crazy. Okay. Notice, be careful about that. If we say some cats named Charlie are crazy, That is not a negation. You have to make sure that you have the fact that there's some cats named Charlie and are not crazy at the end. Okay. So, this second one, if a wife is kind, then her name is Emily. So what you'd have to do is you'd have to say some kind wife or wives are not named Emily. All right. So some are not. This if-then statement is essentially saying all are. So we're saying some are not as the negation. Now, so we've negated an if-then statement here. So let's negate a P and Q. All right, P and Q. Now, here's the deal. When we negate a P and Q, it kind of looks, remember if you recall subsets, and we did this in our set notation, we had A intersect B and we negated it. And it turned out that that was the same as negating A union negating B. Okay? This is one of De Morgan's laws. It basically says not P or not Q. All right. Now we're going to get into the why that is, but think of it as in terms of the set notation. If I said, here we looked at an A and a B, you can call it a P and a Q. Whoops. If I were to shade the intersection, well, we all know where the intersection's at. So if I said not the intersection, well, not the intersection would be anything outside of the intersection. If I say not P, union not Q, well, not P, whoops, excuse me, I shouldn't have done that. Again, we'll do the, goodness, where's my, there it is. We'll do something real quick. So let me rewrite this. So you have P, you have Q. If I said not P, I shade outside of P. If I say not Q, I shade outside of Q. And notice the only thing I don't get again is the intersection. So these two things are the same. They're equivalent. Okay. Now here's what we're going to do. We're going to rewrite the statement. Now I'm trying to take negations. So maybe a better way to understand this is to say, okay, we're going to start with the original statement. The person is a smelly farmer. If we negate that, one way to write it is to say the person is not a smelly farmer. That when I say smelly farmer, I mean farmer and smelly. Okay. Now, if we think about this, when I say the person is not a smelly farmer, okay, it could be the case that that person is a smelly baker or a smelly fry cook or a smelly teacher. And it also may be the case that the person is a farmer who smells good. Okay? That person just can't be both smelly and a farmer. Okay, so another way to rewrite this, which is negating the person as a smelly farmer, is to say the person is either not smelly or not a farmer. It is possible that the person is smelly. Again, like I said, it could have been a smelly baker. It is possible that the person could have been a farmer. Again, it could have been a farmer who smells good. But that person can't be both. All right? So, again, what we're saying here is, if I'm negating not a smelly farmer, what I'm really saying is not smelly and not a farmer. Or excuse me, not smelly farmer is the same as saying not smelly or not a farmer. Okay. Now, again, I already mentioned this, but I want to write it down officially. Okay. If I say the person is not a smelly farmer, we've already rewritten it, so I'm not going to rewrite it. But in the statement, the person is not a smelly farmer, the person could be smelly. The person could be a farmer, right? It just can't be both at the same time. Could have been a smelly teacher, or it could have been a, farmer who smells good, right? So yes, the person could have been smelly. Yes, the person could have been a farmer. They just can't be both at the same time. Now we can negate an or in a real similar way. Again, this is one of De Morgan's laws, but basically almost the exact same. It's you switch the or to an and you negate both parts. So if I say, well, this is one of De Morgan's laws. You can draw this using Venn diagrams. Again, I'm going to skip that. But if I say not P or Q, all right, and meaning both of them, that's the same thing as saying not P and not Q. All right. Now, be really careful about the phrasing here, because a lot of times I can say not P or Q. I don't know if I'm taking the negation outside or the negation inside. So be really careful about the phrasing. All right. So let's rewrite the statement. So obviously this comes from, let's say, original statement. The person is a baker or married. And I say I negate that. The person is not a baker or married. I probably should put the thing there. Okay. So rewriting this statement, which is again negating this, is saying the person is not a baker or, this should be not or, and not married. All right, I stated that bad, but basically, the person is not a baker and the person is not married. Negates this original statement that says the person is a baker or married. Okay, so if I say the person is either a baker or the person is married, to prove me wrong, you have to show that it's not a baker, and you also have to show that the person is not married. And I hope that makes sense. So when I say the person is not a baker or married, could the person be married? Well, no. The person could not be married, because I said it's not either a baker or married. Could the person be a baker? No. The person cannot be a baker in this statement. All right. And I hope that makes sense. Again, it's a little bit sometimes ambiguous where these parentheses should go. But if there's any question about that, I'll write it on the test. Okay. Now, one thing also that on these conditionals is the word some. Okay. We've negated things like all. But let's negate the opposite. Let's negate things like some. And by all, I mean, we have these if-then statements. They could be translated into all statements. But let's negate things with the word some in it. Okay? Now, if I say some x are y, some x are y, and I say, let's negate that. Well, let me first draw a Venn diagram of some x or y. X, y. So all we're saying is there's things in the middle, some x or y. So if I want to negate that, basically I want to say that there's no intersection. Okay? In other words, I want to negate, so this would be the drawing of some x, r, y. This would be no x, r, y. So I want to say there's nothing in that intersection. They don't intersect. Okay? Notice that in this case, to prove it false, you have to prove that there's nothing in here that's in y. All right? So I want you to push pause and negate the following two statements. Some politicians tell the truth, some dogs smell fantastic. Now I hope that you got that down. Basically, to negate some politicians tell the truth, you'd say no politicians. Tell the truth. All right. To say some dogs are fantastic, smell fantastic, you would say no dogs smell fantastic. All right. And so that's how you negate conditionals. Now we've negated ors, we've negated ands, we've negated the word some, we've negated the word the if-then conditional, which is the same thing as negating all conditionals. All. So we've negated a lot of different types of statements. But remember the main point that I made at the beginning. Think of how to prove something false. Anytime we try to negate something, think of how would you prove it false. If I say some politicians tell the truth, well, you'd have to prove to me that no politicians tell the truth. Okay? By the way, there's other ways to phrase that, but I'm not going to go into that. We talked about equivalent statements with no's and all's and things like that. So, but there you go. You can now negate any of these conditional statements that you want.